Welcome back, fellow nerds. In today's video, we continue with more questions about motion. So we'll look at the next question. A tennis player moves in a straight line path as shown in figure P2.8, which is figure. Okay, find her average velocity. Okay, so if you watch the previous video, you would probably notice a certain statement here. A tennis player moves in what direction? A straight line. A straight line you'll have to stick to change in display, change in position, which is distance or rather displacement, right? Final minus initial. That cancels out the idea of speed that we talked about earlier, right? Where you talk about path traveled, which is still the same, but as long as you are in a straight line, it matches almost all position terminologies. You can talk about distance, displacement, because for you to find the difference between the 2 points, it will give you displacement, give you the distance, mathematically, obviously. But anyway, we yeah, I guess to some degree we understand we are talking about the simple final minus initial formula for distance when we are talking about a straight line. Okay, find her average velocity. Now here we are talking about velocity. The previous question was about speed. The difference between speed and velocity is speed is a vector, speed is a scalar, sorry, velocity is a vector quantity. And speed is magnitude, because scalars are only have magnitude. Scalars are physical quantities with magnitude only, while vectors are physical quantities with magnitude and direction, right? Because it is not enough to just move with a certain amount of speed, a certain magnitude of speed. It's not enough to move at a certain speed without the right direction. You cannot reach A. You cannot reach A from B. You cannot reach B from A without moving in the right direction, and that is basically why there is direction when it comes to velocity. And so velocity can either be negative or positive, while speed can only be a positive value, because velocity moving in the negative direction will be different to one moving in a positive direction. It will have the same magnitude, but since they have different direction, which means they would reach different points, different final points, right? I mean, if you move in the north and I move in the south, we definitely are going different final. I mean, despite the fact that you can actually come together, but if we are moving a straight path, we definitely would not cross roads like that, right? Okay, without much conversation, let's get into the question so we can understand more, right? Okay, so so firstly we are going to write the formula for velocity, right? Average velocity is literally the same as, is similar to velocity itself, because again we talked about velocity which is of the same magnitude as speed. You cannot really move, it's not as real to move at a constant speed given maybe a certain longer distance, and so at the end of it all, you are trying to find the overall speed, the overall velocity, right? In a given trip. Okay, so velocity is changing displacement over time, so average velocity will still be changed in displacement, so we said delta x over delta time, right? Okay, so that is basically it. This denotes distance sometimes, but displacement. But then, like we said, mathematically, distance has a similar appearance to displacement, and most likely because we are dealing with a straight line, so not much of a difference. But distance as a terminology on its own is a scalar quantity, and displacement is a vector quantity. That is why I emphasized on mathematically speaking, because distance, mathematically speaking, has a formula that is similar to that of displacement. Okay, so so don't get me wrong on that one. Okay, make sure you get that part. Okay, so let's get into the question. Find her average velocity in the time intervals from 0 to 1 second. All right, so we begin. So A, what is our A? So our A, we'll start with, what is our change in displacement? Let's say our final minus initial, right, over final time minus initial time. Okay, this is how we do it. So what is our final time? So 0 to 1. So 1, so again, this is seconds, this time, right? Okay, this is your time, seconds. Okay, so you say time, this was your this is your velocity, right? Is it? Oh, this is your distance, your displacement. You can say displacement meters, right? Okay, so all right, so in the time interval from 0 to 1. Okay, so from 0 to 1, that is from here, right? From here to 1. Okay, what is our initial distance? Our initial displacement 0, right? Final displacement is 4, right? Final time 1 second, initial time 0. So we have final displacement 4 meters minus initial displacement 0, which does not really change with the units anyway. Time is 1 minus 0, so we have 4 meters per second. That is your average speed, average velocity for A. Okay, so B, you have 0 to 4 seconds, 0 to 4 seconds, right? 4 seconds is here. Okay, again, with velocity you stick to final and initial, right? Does not matter what path traveled, what path length you took, as long as you have final and initial points, you get that when you are finding velocity, right? So what is our initial? 0. What is our final displacement? Final displacement 4 is there, so final displacement is -2, right? So okay, so for B you have final -2, initial 0. You can just do that. It was 0 to 4, right? So you have 4 minus 0. Okay, this is what? Seconds. So you have this is -2 over 4. This is that is half, right? So you have -0.5 meters per second average velocity. Okay, so this is literally saying you have a speed of magnitude 0.5 meters per second, but since it has a negative direction, average velocity. You do not have to forget direction when we are talking about vectors. If you even remember the videos on vectors, we are so adamant on direction, so you do not forget direction, very important. Okay, so we are going on C. Okay, going on to C. So C is 1 to 5 seconds, right? 1 to 5 seconds. Our initial is 1, our final is 5 when it comes to time. All right, so let's see, where is 1? Where is 1? So 1 is here, right? This is 1. Okay, our initial there is 4. Okay, 4 meters. Then our final is at 5. Where is 5? 5 is there. 5 is at 0, right? So it does look like our average velocity will be, our final is 0, our initial 4, okay, meters, over our final time is 5 on the time. Our initial is 1, okay, our initial is 1 second. So we'll have average velocity is equal to -4 meters over 4 seconds, which is basically -1 meters per second. Okay, all right. D, we go to D. Okay, so that is okay, so we, all right, so this was -1 meters per second, right? Okay, so average velocity for the last one, AV is 0 to 5 seconds, right? So 0 to 5 seconds, we are going to have what? 0 to 5 seconds, we're going to have what? Okay, so our initial time is 0, our final time is 5 seconds. Okay, our initial distance is 0, and our final time and our final displacement, sorry, is 0. So literally have 0 minus 0 over 5 minus 0, which basically is just 0, right? AV for the last one is just 0. You can either say 0 meters per second, doesn't change much, right? But you can always stick to units. Okay, well, basically this is about this question. I hope we have learned something, and I know we will look at more questions on motion, so we can continuously cement on the concepts that we are trying to grasp from the topic. Thank you so much. I hope we meet in the next video. Thank you so much.